All right, welcome. So we are going to jump into the first thing you need to know, which was significant figures. Why does this keep happening? Let's try that again. So Sig Figs, what are they, and why do you need them? That's right. This is usually the question you ask in most of your classes. And remember, with all this, you're going to have to tell me the answer to this. Like, why should you care? I want you to tell me. So we're going to look at making measurements and those measured numbers again. So these are those things that you needed to know. We already said measured numbers comes from measurements. So if you ask the question, like, aren't all numbers measured? And that's not necessarily the whole story. So measured numbers can tell you two things from any number given. It tells you the number measured, right? So if we say 3 centimeters, you measured 3 units of scale in length. It also tells you how precise the measurement was. So was it 3 centimeters or was it 3.00 centimeters? So in your activity you did before this, you measured the volume or calculated the volume from all of these different areas. Your numbers may be different for your specific example, but what I want you to realize is when you read the graduated cylinder, each of these little tick marks equals 10 milliliters. And then there's the halfway point, which lets you know it's 5 milliliters. But that's about as precise as you can really be with this. So you can estimate that this is more than a half, and you can count the tick marks. This is 200, 210, 220 over that 5 mark, and it's not quite to halfway, so we can say it's about 227 milliliters. So whenever you are taking these measurements, you should always be doing it to the specific precision of your scale given, out to one estimated place. So as soon as you can't really tell specifically what it is, you can eyeball it, and that's about as far as you can estimate. It gets a little trickier when we look at the volume here. So when you measure this out, you can tell that this is centimeters. You can see it's 6 and then out to one more little tick. And it looks pretty dead on to me. So you can estimate that last point. So if you're doing this in centimeters, it would be 6.10 centimeters. And if it was millimeters, since there are... I can't even think right now. You get the conversion. That many centimeters, when you go through your dimension analysis, you'll come out with 61 millimeters on the other end of it. There's a separate video if you don't know how to do the whole decimal moving of this bit. And then same thing with the volume of the beaker. Again, you're just going to read it. But since our smallest tick mark here is halfway between 200 and 250, you know halfway between that would be 225, but we're underneath that. So it's going to be less than 225. So if I had to eyeball it, I would guess it's about 220 milliliters. And then... if you didn't figure that out before, the 1 milliliter of water, specifically H2O, is equal to 1 gram. So this is equal to 228.45 milliliters if we were talking about volume. So this one's a little sneakier. It's a conversion based on known properties of water. So if we were to ask ourselves, are all numbers measured? Yes and no, right? Numbers let us know how much of something there is, but it's that same idea when we were talking about one what, right? So when we were saying how many of things, that's a count. And counts aren't exactly measurements. It lets you know the amount, but not necessarily what thing it is. Because like 3 of something can be 3 millimeters, 3 heartbeats, 3 eggs. So there are actually 2 different kinds of numbers. We're going to look at measured numbers and exact numbers. And the main difference is measurements are as precise as you can measure to. Like that's the second thing measured numbers tell you, right? Is how precise it is. So how many decimal points you give tells you how precise that measurement was. So I can say the stool is 51.45 centimeters. An exact number is going to be no uncertainty. And this is where counts fall into. So when we talk about counts, we can say there are 12 chairs, right? We're not sure when we measure something if this is more or less specific because we're limited by the scale of our ruler. There is no uncertainty in count. There are 12 chairs. There either are or are not. So these are perfectly exact numbers. So another way to think of this is they are infinitely precise, right? It is 12.00000 going out to infinity. There is no doubt that there are, and there are going to be numbers that are exact numbers that have decimals. So it's not just whole numbers either. So for example, when we talk about conversions are exact numbers. So when I said 1 millimeter of water equals 1 gram of water, this is a known fact. When you convert from milliliters to grams or vice versa, that's an exact number. You would not count any of these things when we talk about how to use significant figures. Exact numbers don't go into that. So anytime you're going from anywhere in the metric system, if you're going from millimeters to centimeters or otherwise, right, you're going to divide by 10. So this was that whole thing I was talking about in that other separate video. If you don't understand this, there's a video you can watch in the library. Or even if you're going between measurement systems. So if you're going from pounds to kilograms or vice versa, that is still a conversion. So counts are going to be exact numbers, and conversions are going to be exact numbers. There's one other example that's going to show up, and when we do some calculations, what we're going to find are defined constants. So when we did our example of the dimensional analysis, we were talking about the speed of light. The speed of light can be measured, but this is something that we've calculated with math. So the way we define the speed of light is exactly 299 million, 792,458 meters per second exactly. And the reason we say exactly is because it is an exact number. So don't let these kind of ones that almost look like they're measurements seem like they're supposed to be significant figures, because that will mess up your calculations. Okay, and the reason why this is important is any calculation, anything you do, when we did that volume, we had to multiply out the centimeters by the centimeters to the centimeters. Every time you compute, you multiply, subtract, divide, any of that, you're going to end up with numbers a lot of times with more number places than you actually know, right? So if we only measured to 10.50 centimeters and we multiply that 3 times and we cube it, you're going to end up with this number. So if you actually count how many numbers you know, we started with 4 places and then we ended with 7 places. This makes us look like we're a lot more certain than we really are. Same thing when we add up numbers, right? So we have 2 numbers here, we have 2 numbers here, and 2 numbers here. When I say numbers, I'm talking about places because it gets a little weird when you get into the rules. But if you add it all up, you end up with 100.61 millimeters. So we went from 2 places for each of these to 5 places. And some of these are different places, right? Because we added hundreds in a tens place. I'm sorry, tens in a ones place. We added a 1 in a tenths place, and we added a tenth in a hundredths place. So that's how we ended up with this number that has more places at the end of it. But we want to make sure that we are being as clear as we can be with how precise our numbers are. And this is where your calculations can give off the idea that you will know more than you actually do, right? We just said you end up with more places than you actually know. So when we say lying numbers, that's what we're talking about. So if your measurements, your calculations are only as precise as your worst measurement, when you do any kind of calculation, you want to make sure the answer you give is only as precise as your worst number. If you give anything beyond that, even though you have all these numbers and they feel like they're real, you're lying. Those are lying numbers. So if you're not sure, why would you want anyone else to think you are? And this is the job of significant figures. So in the next activity, what you're going to be doing is learning the rules of what it means when you're going to round and where based on how precise your measurements are. There are different rules for addition and there's different rules for multiplication, and I'm hoping you'll be able to explain to me why by the end of it. So go learn those significant figure rules, and I'll see you in the next one.